Hello everyone. In this video, we will go through the derivation for the mean and the variance formulas of the binomial distribution. Recall the binomial probability distributions. We have the PMF equals NCX times P to the power X times the factor 1 minus P raised to the power N minus X, where N denotes the total number of trials, P is the probability of success, and X is the number of successes in N trials. The mean of the distribution is N times P, and the variance equals N times P times the factor 1 minus P. And here we are going to derive the mean and the variance expressions. Let's start with the mean. Mu equals N times P. We start with the definition of the expected value of X, which is the summation over all possible value of X. In the binomial distribution, X can take on value 0, 1, 2, up to N. Sum over the expression of X times P of X, where P of X is NCX times P to the power X times the factor 1 minus P raised to the power N minus X. And here, for X equals 0, which is the first term in the expression, the whole term equals 0. So instead of starting X equals 0, we can replace it by X equals 1. And then expand the NCX expressions as N factorial divided by X factorial by N minus X factorial. The next step, I'm going to simplify the expression X over X factorial. Replace it by 1 over X minus 1 factorial. I have the X in the numerator and the X factorial in the denominator. Simplify it as X minus 1 factorial. And then expand the term N factorial as N times N minus 1 factorial. And the factor P to the power X expressed as P times P to the power X minus 1. So we have the following expression. The N factorial is replaced by N times N minus 1 factorial. And the factor P to the power X is expanded to P times P to the power X minus 1. The next step, convert the expression N minus X. This expression is in the denominator, N minus X factorial, as well as the exponent in the last term. Replace by the expression N minus 1 minus X minus 1. So we get in the denominator, we have N minus 1 minus X minus 1 factorial. And the last term, the exponent, becomes N minus 1 and then minus X minus 1. We are going to show that the expression in the summation is in fact a binomial PMF. The next step, replace the occurrence of X minus 1 by K. Here we have X minus 1 factorial. Change it to K factorial. And then this term X minus 1, we can convert it to K. We also have the occurrence of X minus 1 in the exponent. Change this to K as well. And then K equals X minus 1. So we will convert the summation. Originally start from X equals 1. When X equals 1, K equals 0. So we have the lower limit. k equals 0. And then the upper limit of the summation, originally it is n, x equals n. When x equals n, k equals n minus 1. So this is the new upper limit. The next step, replace the expression n minus 1 by m. So we get the n minus 1 factorial in the numerator and the expression n minus 1 in the denominator. Change this to m. And then in the exponent of the last term, we also have the expression n minus 1. The upper limit of the summation, this is m as well. So you can see the expression in the summation is in fact a binomial PMF. You can compare this with the original expression, NCX, and now we have MCK. P to the power x, we have P to the power k, and 1 minus P raised to the power n minus x, we have 1 minus P raised to the power n minus k. From k equals 0 to m. So this expression equals 1. And we get the mean expression for the binomial distribution, mu equals mp. Let's take a look at the variance. The variance expression for the binomial distribution is n times p times 1 minus p. We will do the derivation with the following outline. First, we will obtain an expression for the expected value of x times x minus 1. This equals to the expectation of x squared minus x, which equals the expected value of x squared minus the expected value of x. And then we solve for the expression, the expected value of x squared. Once we get the expected value of x squared, which equals the expected value of x times x minus 1 plus the expected value of x, then we can plug into the variance formula. The variance of x equals the expected value of x squared minus the square of the expected value of x. We already get the expected value of x is n times p. We need to get the expected value of x squared. To get the expected value of x squared, we obtain an expression for the expected value of x times x minus 1. This is the outline of the derivation of the variance expression. Start with the expectation of x times x minus 1. So we have the summation of x times x minus 1 times p of x. When x equals 0, the expressions equals 0. And then the second term, when x equals 1, we have the factor x minus 1. So when x equals 1, this term becomes 0, and the whole term is 0. So we can skip x equals 0 and x equals 1 in the expression. We start the summation with x equals 2. We do the same trick as for the derivation for the mean. Express x times x minus 1 over x factorial as 1 over x minus 2 factorial. So we have the x times x minus 1 in the numerator and x factorial in the denominator becomes x minus 2 factorial. And then express the term n factorial as n times n minus 1 times n minus 2 factorial. And the factor p to the power x as p squared times p to the power x minus 2. So we get the following expression. Next, express the term n minus x as n minus 2 minus x minus 2. So the term x minus x appears in the denominator as well as the exponent in the last factor. Again, we can show that the expression within the summation operation is a binomial PMF. Let k equals x minus 2 and m equals n minus 2. We get the following expression. The summation of n factorial over k factorial times n minus k factorial times p to the power k times the factor 1 minus p raised to the power n minus k. And this is the PMF of a binomial distribution. And we get the expected value of x times x minus 1 equals n times n minus 1 times p squared. All right, we get the expression. We can get the expression for the expected value of x squared. The expected value of x times x minus 1 is n times n minus 1 times p squared. And the expected value of x is np. So the sum of these two expressions is the expected value of x squared. And then the variance of x equals the expected value of x squared minus the square of the expected value of x. Simplify the expression. We get the variance expression for the binomial distribution, n times p times the factor 1 minus p. That's it for today's video. Thank you for watching. In the next video, we will go through the hypergeometric distribution.